Yeah, I believe everyone can hear me. Today we'll be going into server-driven UI in Flutter and start by introducing what server-driven UI is. Now, essentially, server-driven UI is an architectural pattern where the entire UI is driven by server components. In this case, you can design it however you want, but in most of our demos, we'll be using JSON schema. Essentially, what we're used to is client-driven UI, where you write all your Flutter widgets on the client, and then the client manages the rendering of the UI to the user. But in this architectural pattern, what we do is we define what our UI is going to look like on the backend. And okay, yeah, so we define what our UI is going to look like on the backend, and then we can pass that backend data, which could be in JSON, to our Flutter client, which we know then about, which is called the renderer, to render our UI from the backend. Now, in the next slide, we'll see why do we need dynamic UIs. Well, some of us here are mobile developers, and we've all faced different types of issues. Whereas you want to push a new have a release cycle, whereas you want to push something to GitHub or you want to push a new feature to your users. Now, in the traditional ways of pushing new features, what you have to do is go through a release cycle. And some of us are familiar with how difficult the App Store release process can be. It can take several days. It can tell you, oh, you have to change some issues in your pod files, as the case may be. With server-driven UI, we can make rapid deploys and test changes on the fly because our entire UI is being defined on the backend, meaning that we can make backend changes and then immediately all users can see what we've changed or new features as quickly as possible. Now, if we take a look at the components of server-driven UI, we have three major components. The first part is the schema. The schema essentially could be in JSON, and JSON is usually preferred because JSON already has a way for us to structure in terms of columns, components, and text. We also have the second part, which is the blueprints, which is also so we have the blueprints, which is how we define that JSON schema. So think of it like you're being an architect, and then you've drawn out how a house is going to look like, and then someone's going to go and build it. And that brings us to the renderer, which is your Flutter client. And then this, in a real sense, would act like the builder who actually builds your house by taking that JSON schema that it has received and then converting it or painting, as we like to call it, painting the UI with these components. Now we have this diagram. It shows, this is more of an architectural diagram that shows a little bit of how the flow would work in practice, where you have a backend system that sends JSON schema data to our Flutter client app, and then the UI paints on the fly or on the go. Now, why does it matter? Fast iteration and experimentation. Some of us are familiar with concepts like A/B testing, where you need to test two different types of features and how users react to these features. So this is something we can do easily with JSON schema with server-driven UI, whereas you don't need to send go through multiple release cycles to test two different features, right? We can immediately have two versions of our JSON schema and show it to different user groups in things like A/B testing. We can also personalize layouts per user, thinking of things like accessibility and collecting data during sign up. We can then decide how can we render a certain set of components to a certain user set on the fly. And like I said at the beginning, no app redeploys required. Like I said, sometimes deploying to the Play Store and the App Store can take days, depending on what your issues need. In this case, you could just make a quick change on the back end, and then you would see your live updates on the fly. Now we go into demo one. Now demo one is just a simple component we're going to try and render. Now if we take a look at our code snippets, hopefully everyone can see our code snippet. What we see is a JSON schema that has a type and is defined with various properties. We have the type, button, text, which is add to cart, and then the styling. Now, just from looking at this, it's very descriptive. You can already tell what the UI is going to paint based on that, and then we just go into best demo. Please. Okay, yes. So I hope everyone enjoyed my this demo video. Now, what we have on the screen is what we call the renderer. Now, I want to talk about this part because this is the part that really concerns us as Flutter engineers most of all. Because with the renderer, we have to design how this layout is going to look. Basically, think of it like an orchestra or something like that's going to say, okay, I've gotten this JSON schema. This is exactly what I'm rendering when I get this type of behavior from the backend. And then if we take a look at our S0 widget, it handles all this for us. Okay. And then we see some real world use cases where we have user cases in e-commerce where you can personalize product banners, cater to different user segments, different generate dashboards or through SDUI components, and A/B testing as we've mentioned before. And then we just see something similar, some images showing dashboards, e-commerce store, and A/B testing. In the case of dashboards, you can see different users may have different data sets. When you have the data sets for these users in, if you think of it from an architectural point of view, when this is generated on the backend, we can then populate that data directly into our JSON schema without having to manipulate anything on our clients, so long our renderer has been configured to that match that JSON schema, then we would have dashboards that are catered to different user sets and based on different types of data. Now, we've talked about some of this already. So we have the components involved, which involves a backend, which generates and caches schema. You can integrate AI into personalized layouts and it validates the JSON delivery. And then we talk about something interesting like the MVVM and using Riverpod. Now, MVVM, for those of us who are not familiar, is the model view model architecture. And then we architect our app in such a way where we can manage our state and our state updates effectively using this. And then we have our next demo is demo 2, where we use a more complex layouts with more components, and we can see how that's going to be rendered on the screen. Okay, so in that demo, we saw a more complex use case where we have columns of and different components coming together to build our entire layout. Now, we all know if we can use columns, we can also pass in different types of rows and then define more complex layouts. You can even generate your entire home screen on the backend and then send it to the client to render personalized to different users or depending on the kind of test that you're trying to perform. Now, like I said, if we take a look at this, our snippet is our SDUI widget, and it just shows us our more large view of what we talked about earlier when we think about the renderer. And I keep on referencing this because it's one of the core components in server-driven UI. How we define our renderer is really essential to the entire, into how the UI is going to be rendered. And when we go further, when we reach towards final slides, we'll see how big companies use this. Now, if you take a look at the slide, the architectural diagram we have would answer a question as to one of the drawbacks we may have where you may think, oh, do we have to always wait for the load on the UI to render? Well, in this case, we can actually use what we call prefetching and then fetch the JSON and data for the UI before the user opens the app. We can do it in the background, and then we can still fetch or make our API request on the fly or on demand, as the case may be. So we prefetch the UI, and then we can then fetch the data to populate the UI after, and then that allows us to build upon. It'll be very With this, we can then create experiences very closely to the regular clients or client-driven UI that we're all familiar with. Now, we have some major companies that have published articles on this and how they're using server-driven UI. We have Airbnb, which actually created an entire in-house system called the Ghost platform to manage how they were using server-driven UI, defining different JSON for them to render UIs on the fly. We also have Yelp, which has the Chaos platform, and we have Zalando, and they have the AppCraft platform. Now, these companies have taken the concept that we're talking about and built in-house frameworks around this. And in the next slide, we'll take a look at an example of how Airbnb uses this in the app that they have in production. Now, if we see, we have the JSON schema that comes from the backend, like we spoke about, and then it takes that and say, okay, this is the type of components, and then it renders it on the screen. Now, if you check out their Medium page, you see a lot more information on how they view this system, but they inherently did a lot of complex architecture on how they wanted to do it. One key thing they did was standardizing how they were making their data fetching using GraphQL and using GraphQL data and making sure they're caching everything properly. And then using that, they can pass this server-driven JSON schema to different platforms. And as you would know, Airbnb actually uses it for all their platforms, web, iOS, and Android, because with that, you can use the same, because they have standardized this with the Ghost platform, they can use the same JSON schema, and then they can have multiple clients renderers. So as the case may be, so you can have a renderer in Flutter, a renderer in React, and these will take the exact same JSON schema that they have generated on the backend, and then render the correct components as the case may be. And then we take some of the benefits of server-driven UI. We have sometimes it can become complex to manage our JSON schema because you need to accurately version them and know when the changes have happened. Because, like I said, if you pass a JSON that's out of date to your renderer and the renderer hasn't been updated to manage that structure, then it would cause unintended crashes. We also have some benefits, like I mentioned at the beginning. We have no redeploys. This is a really big one. This is why I really like this, because like I always say, with the deployment and release cycle process, it can be very long. We want to test our real features on the fly and see how our users react to them. Another one benefits would be personalization and faster iteration, like we've spoken about before. And then the AI-driven part. Now, in this demo, we'll see how we can use AI in generating this JSON schema that we've talked about in this structure of this talk. Okay, so when we talk about how we can leverage AI in generating our JSON schema, if you take a look, as we saw in the code, I use the ChatGPT OpenAI completions components to generate that and put in the system prompt, and it gave us schema that we have defined. Now, if we go back towards the three components of server-driven layouts, and we take the server aspect of it and generating that JSON schema, what we can then do is, if we have a situation, and a real-world example of what we can use this for is we have a situation where we notice the bounce rate of a certain type of user is falling off at a certain point. With this, we can say, okay, to ChatGPT, we've noticed this type of user has been dropping off for this part at this section in our onboarding flow, and then we can remove it, remove that part of our body flow, that part of the JSON description, and then send it out to that section of users, while every other person who doesn't drop off would see the regular intended flow, so that with that we can get more users into our app and then increase our number of signups, or as the case may be in this example. Now, key considerations, like I mentioned before, we need to think about schema caching. You don't want to refresh on the SDUI component all the time. We want to have a caching layer where we can store this. And then if the schema already exists, then we can just go from there and then re-render or render what's needed without having to hit the API multiple times. Versioning, you need to obviously track the versions of your schema. With this, like we do with API versions, you need to track the versions of the schema and then ensure that the front end is structured to align with the version that we have. We also have performance optimization. Optimizations could also include things like caching, ensuring that the user has the right layouts and things like that. And like I said, validation and AI guardrails. As we all know, sometimes DeepSeek or OpenAI models or different models, as the case may be, may generate the wrong schema. We may have a situation where the users are seeing UI that is not the prettiest, as the case may be. And then we may have some security concerns, just like with any AI, any backend architecture or any architecture in software. We need to think about security. We don't want someone to intercept our JSON schema and render to the user something that may be inappropriate. And then we think about developer tooling support. There needs to be more libraries and more foundational support for this concept. As we saw earlier, we saw different companies have had to build that in-house technology to leverage the benefits of server-driven UI. And yeah, thank you. Question and answer.
All right, thank you very much. Oh, we have some questions. Okay, right.
So I've got two questions. The first one being, if you're using AI to generate the user interface, do you have any recommendations around how you would test that, how you would write the tests for that UI? And the second question would be, how would you observe that as well? Because obviously you want to make sure that when the users are being presented with an AI generated user interface, that any issues with that user interface are being properly reported. Have you got any recommendations that you give to people in the audience who'd be curious about that?
Okay, on the first question, sorry, could you take the first question?
Automating UI tests for...
Okay, for automation UI tests, I would say when we have this introduction of new types of engineers, which we like to call the prompt engineers, and I would say, to automating those tests, we need to create several instances where the AI could generate these models, and then we would test and compare them and then see what our results level are. Then once you've been able to do that, and then you have a high, what's the word I'm looking for, a high understanding of what the AI is giving you, and you're sure of it, so I'll call it trust level. In this case, you've gone to the level, your trust level is at 97, 98%. You can say, okay, yes, we are 100% or 98% sure that the AI will always give schema that is, relevant and that matches with what we have on the front end. On the second question.
The second question was about observability. So in my head, what I'd like to see would be for every user who's presented with some part of an AI-driven user interface, as well as being given all the logs from that session, you'd also be able to see a screenshot of it or something along those lines. Because
yeah, exactly. So I did think about this. Like I said, it's a relatively new concept that I've come up with, but I did think about how can we observe and see what the AI is producing, especially in a production setting. I think one of the things would be when we talk about guardrails, where we have a second layer that validates what's being said to the user and creates, like I said, when we talk about renders, we can create the render on any platform. If we want to create an observability platform for this, we can render it on the web and say, okay, this is what our users are seeing at this very point in time from our AI in that situation. I hope that answers it.
Yeah, that's pretty good.
Any more?
So would you prefer having code push or over-the-air updates over having server-driven UI, or you would still go with server-driven UI if you have to?
When you talk about code push, you're talking about over-the-air updates. It depends on what you're trying to do. I think over-the-air updates can be an alternative to a lot of the things that SDUI achieves. In this case, I do prefer SDUI because of the amount of flexibility you get with it. With over-the-air updates, you're pushing a bundle of your actual code to your users.
Related to the AI question, how do you get around the dynamic problem? I noticed some of the types in there were dynamic in terms of you sort of lose some of the type safety. Is that just part of the trade-off?
Yeah. So it's an early idea that I've had. Was when you take something, it's one of the trade-offs I also noticed in terms of the type safety, and it draws back to the AI guardrail system, similar to what if you look into how Airbnb does it, with their Ghost platform, they have a system that validates every single thing that goes to the users. In this case, we would have to build up our own in-house system that would then validate that all the types are safe. And then in that situation, yeah.
Great talk, thank you. There's been servers supplying UIs for many years, and in the Airbnb case, that it's quite a static layout. So you've got the title and the description and the rating and the comment and so on and so forth. And it sounds like what you're suggesting here is you can actually go one level of abstraction higher, and rather than expecting a title and expecting a description, you're actually describing the first thing you want to render is a title, and the next thing is a description, and the next thing is a rating or whatever. And then if you wanted to switch around the rating or the description, you can just reorder the array in the output. Is that the kind of, are you suggesting that as like an evolution of the rendering, or do you have a recommendation of when to more tightly define the layout versus making it more flexible, and the trade-offs on those approaches? If that made sense.
Yeah. I think in that case, we can look at it as a trade-off that may come, but engineering is all about trade-offs, right? And you have to look at your different instances where you would want to make the layouts a bit more dynamic, where you want to think of it like you want to throw out all the users into the ocean of users that you have and see what sticks. Having a dynamic layout would be a good way to see that, where, okay, a large amount of users have already responded positively to this UI, and then you can then break it down and say, okay, this is what works, and then move back to making it more static and more frequent with the UI that you've decided that works with large subsection of users.
Some over there.
Thank you for the talk. So I can see like three different things. One is you as a developer, when you are defining the UI, the schema. The second thing is when you write the first version of the schema. But the last part is when you hand that over to someone else to modify that schema. Do they work with the text files, schema documents, or do you have something built for the I don't know, UI manager or marketing manager to change the model, change the UI?
Yes. So, like I said, with driven UI, you can build on different layers of technology on top of it. And like what you mentioned is, you can give marketers, salespeople access to this kind of data, and then they can edit it and get the data that they want. If they want to change the text, they do that on the fly using system that we've built to allow us to update this data for the users as well.
So you mean you will have another application for just modifying the UI on top of that?
Yes.
I'm going to be quick. This was incredibly interesting. I'm just curious, how do you define the business behavior? I think on the last example, you had view weather. How do you tell what the UI will do afterwards? Is it going to open a model? Is it going to transmit something? Is it going to redirect you to a different screen? I'm just curious how this works.
Yes. Is the first foundation of what server-driven UI is all about. However, we can define our more complex components of that JSON schema, such as actions and behavior. And then when we receive that on the front end, then the front end will know exactly what it needs to do.
Thank you.
Sorry, thank you for the talk, by the way. As part of the pattern, would you define like a default UI that would render in case that the backend query ever fails? Or
Yes, definitely.
yeah.
In a real-world situation and for in production setting, I would strongly advise to define fallback UI in a situation where, okay, this is where we're going to, or this is the base of the app in a situation where the schema generation fails. Yes, so you can have fallback UIs as part of how you architect your front end if using this.
Thank you.
Any more questions? All right. Thank you very much, Patrick. Round of applause. Thank you.